Fritz
Zwicky was an Austrian astronomer who worked in California. He was studying a galactic cluster named the Coma Cluster. It was the year 1932. Just 3 years before, the American astronomer Edwin Hubble had shown that galaxies are moving away from each other due to the cosmic expansion. While observing the Coma Cluster, which is the largest visible from the Earth, Zwicky detected that the peculiar velocities of the stars in the cluster, that is, the velocities not due to the cosmic expansion, but the ones produced by the gravitational influence of the whole cluster, were very high, about 1,000 kilometers per second. With those speeds, galaxies should scatter all over space and not remain attached to the cluster. But they were kept in the cluster. For this to happen requires some kind of invisible matter, later called dark matter, exerting a gravitational influence to hold together the galaxies in the cluster as a bound system. During the 1970s, the American astronomer Vera Rubin and her team examined again the dark matter. They were studying the spiral galaxies and the rotation speed of the stars around the galactic center. As in the solar system, where most of the mass is concentrated in the center, so too with the Sun in the spiral galaxies, where more or less the same happens. Most of the bright matter is concentrated in the center. Therefore, they expected the rotation speed of the stars around the galactic center to follow the same pattern of the planets rotating around the Sun. By analyzing different spiral galaxies, Vera Rubin realized that the stars rotating around the galactic center did not decrease in speed. The expected results were not the ones coming out from their observations. The stars kept a stubborn, constant speed, spinning at a velocity that did not decrease with distance. This fact could only be explained by the presence of a halo of dark matter in the spiral galaxy. A halo of dark matter that has between 5 to 10 times the quantity of the observed bright matter. Supernovae are so bright that they can be observed in galaxies that are billions of light years away from Earth. That makes them standard candles, therefore allowing us to estimate the distance to those galaxies. When we study those supernovae, we find a surprising result. They are 25% less bright than expected. This fact shows that the distance their light has traveled to arrival with us is greater than we thought. Therefore, if they are farther away, it means that the universe has expanded faster than expected. The reason behind the accelerated expansion of the universe is not clear. Cosmologists talk about dark energy without really knowing what it is. The dark energy is not matter, hence we cannot detect it by its gravitational influence. Neither is radiation. We cannot identify it with our telescopes or other detectors. It is an energy that physicists associate with a vacuum, and it should work as a repulsive gravity. When astronomers put together all relevant cosmological observations, the cosmic background radiation, the distribution of galaxies, the remote supernovae, they come to the conclusion that the universe is made of 5% of ordinary matter. Just 5%. The rest is unknown. 25% would be this dark matter of an unknown nature. Someday, large particle accelerators like the LHC at CERN may well give us clues to its nature. And the remaining 70% would be dark energy. 2,400 years after Aristotle, and whether we like it or not, successors in philosophy and the natural world keep talking about quintessence, about an obscure and dark side of the universe. More than 95% of the universe is made of a substance of utterly unknown nature. We only understand the tip of the iceberg. The rest is a mystery. It will have to be the new scientists, those coming after the current generation, who will be the ones to discover the nature of the universe.